Recording happening. So welcome everybody to what is going to be the final session for this semester for construction. Sorry, not for this semester, for this term. Sorry, and then we've got our mid-semester break. Well, next week we've got marketing and development week, which I'm thoroughly looking forward to, and then of course after that 2 weeks mid-semester break. So a bit of a break for you guys. You won't have to be listening to me rattle on every week. Or at least for 3 weeks. So yeah, hopefully you enjoy that as well and manage to squeeze in a bit of a break there. So today's session is likely to be a bit of a shorter session, and also I've mixed things around a little bit as well. So rather than, like the schedule says, we're going to be covering internal linings, but having a look at the way that things are sort of working between construction materials and construction methods, I thought it's probably better to start aligning some of these lectures a little bit better, so that we're covering topics in construction materials and then the following week covering them in construction methods. Now I know not everybody's doing both construction materials and construction methods, but I think for the majority of you that will work slightly better rather than this rather than following the units step by step in the way that they're laid out, because then it's kind of got things a little bit jumbled. So I've done the unreinforced masonry for this week. So then on our first week back, we'll be looking at unreinforced masonry construction details, and then looking at internal linings, and then for construction methods looking at internal linings, insulation, etc. So I've chosen to just mix things up just a little bit there. So for any of you that are wanting to follow online, so skip the internal linings section and go straight to the next one, the unreinforced masonry, and you can open up the slides there. And then also in that section alone page, I've got just a link to the Think Brick website as well, so the industry body that promotes the use of brickwork within construction. But of course, beyond that, there's plenty of suppliers, etc., that you can do your own research through as well. Okay, so I'll just get my comments up there as well, in case any comments want to come through. And of course, if you've got any questions, do let me know. So first up, TAFE acknowledges the traditional owners of the land on which we meet today, and pays respect to their elders past, present and future, and extends that respect to all Aboriginal language groups gathered here today. So we're going to be having a look at masonry again. So we've, so you guys possibly a little bit sick of masonry thus far, because we've covered it, in terms of reinforced masonry early on, and then within construction methods as well, looking at some of the reinforced masonry in that as well, the details around Caulfield masonry. But now we're having a look at it used in an unreinforced sense. So masonry basically as a cladding product as opposed to a structural product, and that is by far the biggest use of masonry. Basically, if you have a look around a new subdivision, you'll see, in some subdivisions, they stretch as far as the eye can see of brick veneer houses with either tile or custom morb roofs. So there is a massive use of masonry in construction for that brick veneer scenario. So it's an unreinforced masonry, but there's a whole lot of other uses of unreinforced masonry, a little bit more creative than your standard brick veneer as well. So masonry by definition comprises individual units that are bonded together with mortar. So basically that means that really you could get plastic blocks or just about anything bonded together with mortar, and basically it comes under that definition of masonry. But in the main, when we think about masonry, we think about some of the more solid, heavy, hard types of masonry, such as brick, concrete blocks, etc. So yeah, by far the most common we'll see is brick veneer. However, also very many types. And here in this image, we can see that the start of brickwork. So this is the first day's work there up to this point, all troweled off and pointed nicely. And down the bottom here, we can see a weep hole down the bottom. That's to let moisture exit out. Now, for those of you that did the construction methods yesterday with the external claddings, we had that discussion about the fact that moisture does make its way into walls, and the thing is, we always have to ensure that moisture can make its way back out again. So that's what these weep holes are in the brickwork, approximately every 5th brick, to allow that to exit the wall cavity. But some other types of masonry that go beyond just your bog standard brick veneer are concrete masonry units. So we've dealt a lot with those, with the larger blocks, the hollow core blocks like your Besser blocks, etc. Yeah, well, Besser is a product name, but basically those hollow core concrete blocks. But there's also solid concrete units as well, concrete bricks. They're not commonly used, and personally, I think they're a bit problematic. I've seen issues in buildings before where relatively or sort of slightly uncured concrete bricks have been used with fresh mortar mix, and you get a lot of shrinkage over the wall as they continue to cure, and so that can be problematic as well. I've certainly seen plenty of evidence of that in building practice. So not such a fan of them, and it's probably one of the contributing reasons why you don't see them used commonly in your housing estate. But there's also things like glass blocks. So there is, I don't have an image of them, but probably everybody knows that that traditional 190 by 190 glass block that got used in just about everything in the early to mid 90s. But there are some other beautiful glass block products on the market as well. So these ones, who makes those? Can't remember who the supplier of those ones are. Might have to traipse around and find them yourself. But they're called Venetian glass, but they're about $50 or $47 or something a glass brick. So by no means cheap. Typically your standard brick you're paying sort of between $1 and $2, depending on the finish, etc. on those. So horrendously expensive, but also rather beautiful. And then also got things like stone masonry. So this image here is taken from a company's website called Allstone. So Allstone, Adelaide-based company that do a lot of these stone veneers, and they do some really nice ones. Some really cool, inverted commas, high-end stone veneers, ones that look a little bit more like natural sort of artisan approaches to stonework, as opposed to some of your traditional stone veneers, which look very obviously to be stone veneers, let's say. So all sorts of different qualities, or ranges of quality there. And so, and excuse me, I may cough a little bit also in today's session, feeling a bit under the weather as well. So excuse me if I have to do that, but we'll see how we go. So in terms of brick types, there are so many brick types in terms of textures, finishes, etc. That designers have at their disposal for creating various different aesthetics. So certainly the smooth brick, which is very well known, something that really hit its stride in the mid 60s with cream brick, the cream smooth bricks, very popular. Some of your textured bricks, so this extruded rate and wire cut, really hit their stride late 80s, early 90s, and then some of your wood mold bricks, which is a little bit more sort of, I guess, in vogue currently, has that more bespoke artisan sort of rustic appearance, and also sand coated bricks, which so we've got these bricks here. These ones come from, I think they're manufactured in Belgium, brought over, probably pretty pricey as well. They're a bit of a wood molded but slightly tumbled brick with a sand coating as well to really give it that rustic look. So yeah, good for feature elements. Molded bricks, or extruded bricks that have features and textures to them, like this range of brickwork here, or even glazed bricks. So that's whereby you've got that glazing which is fired on, just the same as some of your fired pottery products. And of course, all sorts of combinations of the above features as well. But one thing that most bricks have in common is standard dimensions, and there's a very good reason for that, is because when you start getting outside of standard dimensions, you can really start messing with both bricklayers and designers, because designers, you know, that is yourself included, will, if you're working with brickwork, you'll design around brickwork dimensions. So you'll have walls that have a length of, you know, of a certain number of bricks. So, you know, so we'll have 7 bricks, 7.5 bricks, etc. Hi Scott, good to see you in the session. Right. And so yeah, that's a very important aspect for designers to think about when working with brickwork, is that you've got to be designing for those standard dimensions of brickwork, because whilst bricklayers can stretch things or compress things just a little bit by making their mortar gaps slightly thicker or slightly thinner over a run, it's going to work so much better for them if they're both only cutting bricks in half and then also just doing their standard 10mm mortar gap. So with our standard brick, and this, if you remember anything from you know from the session today, remember this, that they're 230 long, 110 wide, and 76mm tall. So I could not count on all my fingers and all my toes how many times I've had to employ that working in repair and reinstatement from photographs, because I used to do a lot of work here in South Australia, but working for projects in New South Wales and Victoria, and being sent photographs to work from, and sometimes you just don't have the dimensions, and so you're just going through the photographs and you're looking at things in increments of brick dimensions, because that's you know, you can count those off the photographs and get wall heights, wall lengths, all that sort of stuff. So it is an incredibly how to say it, it is definitely something you're going to use. So brickwork dimensioning. And then, of course, with your standard brick being 230 long, 110 wide, and 76mm tall, when you add a 10mm mortar gap, it becomes 240 long and 86mm tall. And it's by no accident that that brickwork dimensions also line up with standard size doors and windows. So in this, we can see a lot of commonality here between brickwork heights and our standard size doors and windows. So, you know, so on the lower, or on the first column here of our windows, the 600 high series, that lines up exactly with the height of 7 bricks. So that opening, so 600 high, and then another 2 bricks is another 172. So we add that to 600, and no surprises there, we get to 772, etc. So windows, standard size doors and windows are manufactured to match up exactly with that brickwork, and would have got some widths as well. So so length of an opening, we've got 970 and 970 here. So Joseph's asking, are there different charts used for the more decorative brick feature walls? Well, you'll find those charts harder to get, and if you're going to be doing some of the more decorative feature work with brick and block work, you typically have to do a little bit of thinking yourself. So it's not just working from charts. Sometimes you will find charts for certain products and find charts for what you're wanting to do. But when you're stepping outside of your standard size brickwork dimensioning, it may take that you, or it may mean that you have to actually do some of that calculation work yourself. But that is an excellent question, because that's, we'll cover that a little bit later on as well. Some of the other sizes of brick and block work and how that works. So in this image, obviously, so we've got some brickwork dimensions happening there. We've got, you know, we can see that all of these windows line up with our brickwork. If I can, oh no, sorry, if I scroll it, it changes page there. But I guess we'll just take it on face value that that the bricklayer here has only cut bricks in half. and so we don't have any thirds of bricks or quarters of bricks or anything like that. But these windows are laid in those horizontal dimensions made up of brickwork dimensions and also our heights of windows as well. Now you'll see underneath these windows there's a bit of a gap there. That's because what happens is that the bricklayers will lay bricks on an angle on their side to create those sills. So that's waiting for that to happen. And so that's one of the last things that gets done by bricklayers is doing all the sills for the brickwork. Also, on the front of this building here, we've got some brick on edge, and that's something that's caught me out a little bit as well. Working as a drafter, you know, as I mentioned before, working a lot from photographs, etc., and information gathered by other people. At times, I have, you know, been given wall thicknesses and things, and thinking like, oh, how on earth is that possible? And it was a bit of a thing that was done in the 1950s, I guess, possibly because bricks were expensive or something like that. But there were some builders that were really scrimping and putting their bricks on edge, because as I've covered before, that your bricks are 110 wide and only 76 tall. So if you tip your bricks on their edge, you can actually get a lot more vertical height of wall by tipping your bricks on the edge. But it's certainly not a common practice, unless of course you're doing something like stone facings or render, whereby if you tip your bricks on the edge like this and have your those extruded cores facing out, it gives something for the adhesive and the or any render to key into. So so that's what's done on this wall here, and we'll have a bit better look at that wall later on as well. And also, not that it can be seen so thoroughly in this picture, but there are also control joints happening here at the side of all of these windows. The reason we have control joints is because masonry units are particularly, or they're not known for their flexibility, basically. And if there is any flex in the slab as a result of flexing or movement in the ground, then that gets transferred directly to the brickwork. And so in reactive sites, we have to have control joints at maximum 5 meter spacings, and for less reactive sites, it's at 6 meter spacings. But whenever there is a window which is greater than 900 high or 900 wide, you need to have a control joint adjacent that window as well. Hence why we've got control joints here at each of these windows. So, so to sort of answer Joseph's question, so in regards to the non-standard size bricks, now I guess you can lump everything. Well, all of your standard size bricks, your 110, 76, 230, is, you know, that takes up sort of 90% of your bricks that you'll ever see, and so that 90% of brickwork sort of falls in that standard size brick dimension. But as soon as we step outside of that, we've got all sorts of combinations and permutations of dimensions. Now, a lot of these dimensions are either what I call metric dimensions or dimensions taken from the standard brick. So we can see this, I can't remember what this particular product is called, but it might be the standard 76 actually, which is, was that? No, that's 230 long. So what have we got? What have we got here? No, okay, possibly it's not one of these products listed on the right hand side. Anyhow, this one is 390 long. So 390 long, you'd probably remember from your concrete masonry units or your Besser blocks. So they're 390 long, but so that's a metric size, because once you add 10 millimeter mortar gap, you've got this round figure of 400 millimeter increments. But it's only 76 millimeters tall, so it takes that 76 from the standard brick. So it's a bit of a mashup of a metric brick and a standard brick. And as we can see on the right hand side here, for this this range of products from a brick supplier that deal in non-standard sizes, we've got some 290s by 90s. We've got 230 by 110. 230 by 150, etc. So as soon as we start stepping outside of the standard 76, 110, 230 brick, we do hit a range of dimensions, and that's what I was saying before, that if you're starting to work in that space of using feature brickwork or brickwork that's outside of standard dimensions, it requires a little bit more more sort of first principles work or working through it yourself rather than just going straight to the standard brick dimension chart. Okay, so one of the Australian standards for brickwork, as you should all know by now, is AS3600, and excuse me, and that AS3600 defines different mortar mixes for different exposure types. So in places where you've got more aggressive conditions, such as building on the beach or something like that, you have to have a higher cement content in the mortar. So your standard mortar mix is 1:1:6. So one cement, 1 lime, and 6 sand. But your higher strength mortar mixes increase that amount of cement in the mix. That helps to hold all those sand particles better into that mortar mix in aggressive environments. So coastal environments are quite aggressive for mortars, because what happens is you get salt-laden moisture deposited on that mortar, and the mortar soaks it in to a bit, and then it dries out and it leaves those salts behind. Those salts form crystals and start wedging off tiny little bits and pieces of that mortar. So we're talking sort of at the granular level, like tiny little grains of sand, but the salts being deposited do that. So if you've got a higher cement content within your mortar, it resists that action and also makes the mortar less pervious. But one of the downsides of a higher cement mix in a mortar is less flexibility. So masonry is certainly not known for its flexibility already, but the more flexible element within a masonry wall is typically the mortar. And so that's when some of your older walls, which are very lime-based walls, there's actually a fair bit of flexibility that can happen within those walls to take up ground movements, etc., and shifting foundations. But when we think about the structural role of mortar, we've got to think of mortar as that it's not so much there to hold the bricks together like a glue, but it's more there to hold them apart. Mortar works in a compressive sense rather than a tensile sense. So it's, whilst your higher cement mortars will bind significantly to that brickwork and essentially glue them together to a greater extent, still the overriding function of that mortar is to hold those masonry units apart, so to work within compression. And those mortars, just like your varying range of brick appearances, there are a range of mortars as well. However, you don't quite get the color variation and so on with your mortar as you do with your bricks. They're either going to be somewhere in that range of sort of creamy whites to dark charcoals. So that's pretty much the range of mortar colors. But it's a very important thing for designers to ensure that mortar mix or that mortar color is going to work well with the intended brickwork as well. So Rebecca's saying, what category does stonework without mortar fall into? So that's what's called a dry stone wall. Interesting one. Because I guess the definition of masonry is that it's a separate unit bonded together by a mortar mix. Interesting. Look, I don't know. Is a simple answer to that question. But basically, it's when you have stonework that is just laid without mortar, it's called dry stone walling. Great question. Cool. But also with your mortar, it's not just about the color variation and matching your colors well to your brickwork. It's also about matching that aesthetic of the mortar or the way it's finished or way it's pointed to to what you're trying to achieve as well. And there are a whole host of ways in which brickwork can be pointed. So pointing relates to the finishing of mortar, and this happens after the bricks are laid. So the bricks get laid, and the mortar gets troweled off on a really rough fashion. The bricklayer just runs their trowel sideways across that across the front face of the brick there, trims the mortar off or trims off any excess mortar. But then once that mortar is consolidated a little bit, then goes back and points that brickwork. And so the pointing of the brickwork is both and serves both an aesthetic function, but also a structural function, in that when you go along and you clean up that mortar, what you're doing is you're compressing the surface a little bit, and you're bringing some of that water out of the mortar mix there, and bringing some of the cements to the surface and giving a harder edge to that surface. So it is also slightly a structural practice as well. But there are all sorts of different pointing approaches that you can take. So things like concave, that's something we see, you know, a lot for your standard brickwork, and also just this simple raked joint as well. So both the raked, concave, and then flush to an extent. So flush is a bit of a, I guess, a modern architectural approach. And also the deep raked mortar was something that was sort of a bit of a thing in the 70s, 80s, and 90s for some of your more brutalist type buildings. It was a bit of a feature as well. Beyond that, you know, you won't see the weathered or the struck very often, or the V so much. But certainly the concave probably wins out in terms of frequency of use. So Joseph's saying, is it structural? I guess that's relating to dry stone walling. So dry stone walling can be structural, but you wouldn't rely on it as load bearing. So there are, I guess, for those interested in these sorts of things, there are all sorts of amazing constructions around the world that have been done by dry stone walling. So you can see some really interesting stuff in places like Italy, or I was in a country called Georgia, which is sort of between Turkey and Russia there, and up in the mountains there's a whole host of shepherds' huts which are made of large slates, all stacked together, and then using larger slates for the roof in a sort of in a curved fashion, or an arch fashion, that transfers the loads to the outer walls. You know, none of that has mortar in it whatsoever, but basically using the weight of that stone to lock itself into itself and transfer all those forces to the ground certainly works in a structural fashion. But yeah, certainly we would not see dry stone walling used in a structural sense here in Australia. So is it much used in today's building practices? Certainly not dry stone walling. You've got a bit of dry stone walling that happens in landscaping. So yeah, so for some of your basically for a stonemason, to be building things with dry stone is about the zenith of their skills, because what it means is that they end up not relying at all on the mortar to assist in the bedding of rocks. And so it does take quite a skilled tradesperson to actually build significant dry stone walls, because basically what you've got to do is ensure that all of your forces, all of your transfer forces within the wall are actually holding that wall together, which is a bit of a trick. So yeah, look, I think that's certainly a course of study which you could definitely embark on, separate to this. But you do see some of that dry stone walling about the place, used mostly for landscaping. So the masonry properties, it very much depends on the masonry units. So you know what those masonry units are, but our most common masonry units, of course, are brick and concrete blockwork, and they are typically high in compressive strength. They will also typically have a very high thermal mass, so they'll take up heat and give out heat slowly. Also very durable products, and quite heavy. So weight is a massive consideration in masonry, but they're also notoriously inflexible. So some of your building cladding systems can hide movement a lot better than your brick veneer, and that's why within brick veneer you have control joints built in everywhere to take those that bending and expansion and contraction of a brick veneer wall. So within the NCC, it's within AS4773. It sets out that you have to have expansion and contraction joints and articulation joints, and it sets out the various requirements for both of those types of joints. But what typically gets done is the requirements for both of those joints get brought together, and we get that resultant rule that these brickwork control joints have to be spaced at 5 meter maximum centers for in reactive soil situations, 6 meter centers for your medium to high reactive situations, and then at the edge of any window or any penetration in the wall which is greater than 900 millimeters, either high or wide. So these brick control joints, they handle both expansion and contraction of the units, and also articulation of the units, so flexing of those walls. And here in this image here, we can see that it's something that is Adelaide's notorious for, is basically cracking in masonry buildings. So this would be a cavity masonry wall, wouldn't be a brick veneer, just judging by the type of window there, but all the contributing factors are the same there, in that masonry units are inflexible and there's no brick control joint adjacent this window. So what happens is when you get flexing in that structure, it simply starts snapping through the brickwork. And this one, or that sort of snapping is, to my eye, is possibly a little bit more concerning than when you get to the stepped cracking. So the stepped cracking is something you see a lot, right, where you get this stepped cracking along the mortar work, etc., emanating from a corner of a penetration. That's a fairly normal thing to happen. But when you get shearing directly through bricks, so we see this brick sheared through directly, that one sheared through directly, that one sheared through directly, also this one here, that indicates to me that there's quite a concentration of forces happening in that wall, that we've got both possibly both expansion and subsidence happening very close to each other. Whereas when you get that diagonal cracking, it typically is more indicative of a not a concentration of forces, so to speak. But here on the right hand side in this picture here, we see that that brick control joint which has been imposed in here, and that's going to get filled with a foam and possibly a mastic on the outside. So there are several different approaches to creating brick control joints, and we'll cover that in construction methods. But that enables that flex in the wall to be taken up by that. So masonry applications, used significantly in housing estates. That is changing, however. So yeah, I think I mentioned it previously. The cost of bricklaying has gone through the roof. Now I'm not sure what it costs per brick to lay. I haven't asked any bricklayers what it's costing to lay a brick at the moment. But yeah, your laying of bricks is thoroughly expensive at the moment with the whole demand which is in the sector at the moment. So because of that really high cost of bricklaying, because you can't just automatically produce more bricklayers on demand. It is a skill which is developed over time. So there's no tap you can turn on for bricklayers. It's getting quite expensive, and that's actually driving a bit of a change to what people are specifying in terms of some of your volume builds. So going more with rendered Hebel approaches, so where you got your 75mm power panel walling panels, which are screwed onto with a gap onto your timber frames and then rendered on the outside. That's gaining in popularity. But still, if you were to drive around any recent estate or housing estate since 1950s basically, you'll see predominantly a sea of brick veneer houses. So used significantly in housing estates, but then also used in some high-end architectural builds as well. So some of your feature masonry, your metric blocks, all that sort of things, masonry, which does create features, even those glass blocks, all that sort of stuff does get used in high-end architectural builds as well. It is suitable for bushfire prone areas if detailed correctly. So if I rewind all the way up to this guy here, we can see right down the bottom here there is a brick control joint. Sorry, not brick control joint, a weep hole in the base of that brickwork. That weep hole is great for letting moisture out, but it's also really good for letting embers in. So within bushfire prone areas, those weep holes have to have these little flaps. So they're these little weepers, they're called, that can get that you go along and you push into those weep holes afterwards, that still allow water to come out, but will stop embers going up into there. So that's the main consideration with using brick in the bushfire prone area. Beyond that, of course, yes, brickwork is vulnerable at its brick control joints, and your foam infills to that are vulnerable to that. But another way of doing a brick control joint is to put a 10mm backing rod, or we'll use a 12mm backing rod so it squeezes down a little bit in here, and then have a fireproof mastic over the top of that. And mastic is it's something sort of akin to silicon, but it's not exactly the same. Basically, what a mastic does is the outside of it sets like a rubber, but the inside of it stays quite soft. And what that means is that it bonds well to whatever it's squeezed into, but then extends significantly, so it has a high extensibility. Yeah. So and possibly we can cover mastics and things a little bit later on when it comes to some of the other products. But that's also possible to treat some of those details like that. And then of course beyond that, other brick veneer walls, other vulnerable points are at junctions to eaves, etc., and the detailing around that. Brick veneer is also suitable for coastal areas if constructed correctly. So some of the extra things you have to do for building in saline environments are obviously a much stronger mortar mix, so higher cement content to reduce its permeability or its propensity to take up moisture. But then also you've got to use stainless steel brick ties as well. Now there are plastic brick ties on the market. I think well, look, I don't have any experience with these plastic brick ties failing myself, but a word of warning is that you know, pretty much any of your plastic products do have a finite life. And whilst I haven't seen plastic brick ties fail, I have seen other dodgy approaches to brick ties failing, and the results could be quite catastrophic. So probably the most notable was a repair job I worked on in Norwood, where a Besser block wall fell on some of the shops nearby. Yeah, basically because of the detailing around the brick ties for that. But so brick ties, you know, and we'll cover this in construction methods more. It's more of a construction methods thing. But yes, but in saline environments, use the stainless steel brick ties and not the plastic ones. But they can't be rust prone. Basically, is the thing. Some of the limitations of masonry. So given the weight of masonry, it can add significantly to footing costs. So, you know, it's not unheard of to have, you know, 20-ton or so of brickwork or pallets of bricks delivered, and all of that gets then imposed on your footings. So your footings do have to carry a lot of weight when it comes to brickwork, a lot more weight than if we're talking some of those lightweight cladding products that we're looking at in construction materials. Previously. So yeah, so it is heavy. And you've got to counter that, and it's both heavy and inflexible. So it does mean that your footings have to be significantly more to carry that. Also, given the weight and the volume required, it can be uneconomical for remote areas. So I'll put Kangaroo Island there as one of those situations where you'd think twice before specifying Brick Veneer on Kangaroo Island, because it is just so expensive to get things over there that if you're talking about large volumes of things required, you pay for that transport. So yeah, like Kangaroo Island particularly, because the ferry across there is just thoroughly expensive for taking large deliveries on. But it's not only Kangaroo Island. It's also other areas, remote areas. If you building a house in in some of the station areas, it's also unlikely that you'd specify Brick Veneer because your transport costs of materials up there. You can get a whole cladding system of fiber cement sheet on half of a semi-rigid. So you've got in comparison to like a whole semi-trailer for your brickwork, so or possibly more. So yeah, the sheer volume required can certainly be a limitation as well. Some other masonry limitations is also the typical application of unreinforced masonry as brick veneer does not contribute towards an energy efficient home. That's because all of your thermal mass from that brickwork is on the outside where you're not using it. However, it does contribute significantly to embodied energy. So there's a great deal of embodied energy that goes into the firing of bricks. So we've got that baking process. And so if your aim is to build a house and then get it on the Sustainable Building Network Eco Homes Day, you're not going to use brick veneer, basically, is the thing. Or if you are going to use brick veneer, it's going to be reverse brick veneer. And we'll cover that a little bit more. How many slides now? It's just a couple slides now. Right. So in terms of the general sustainability, apart from the sort of energy efficiency and embodied energy, once again, it depends on the masonry material. Natural stone, of course, has a very low embodied energy. And if we start thinking about your dry stone walling, of course, we can have basically a zero embodied energy. If we're picking up the rocks from where we're using them, there's only a bit of human energy in there, a couple of sandwiches, and we've got the energy covered. Whereas, with things like fired brick, glass, they have a very high embodied energy because those materials have to be thoroughly heated and baked. Also, large volumes are used in construction along with mortar mixes. So it's not only that there's a high embodied energy in the units themselves, but a lot of units are used. And then you've also got your mortar mix, which contains cement powder, and that cement powder is the high embodied energy component of concrete as well. But it is a non-toxic product. So they're, typically, like if we talk about bricks, they are simply clay that has been fired. Now there are, I guess, some oxides and like copper oxides and things like that used, which you probably don't want to go putting in your mouth. But in the main, we're talking about non-toxic materials and products used. And those materials are naturally derived as well, so not synthesized, and there's no flow-on effects of byproducts of production, so to speak. Apart from the gases put out from firing that clay. But these natural materials are non-renewable, and they rely on supplies of clay and building sands. And look, I guess if we think about it. Well, on the face of it, it appears things like clay and sand. There's way too much clay and way too much sand everywhere. We're not really at risk of ever running out. But your higher quality products that are required for both the good quality clay for producing bricks is not, you're not going to dig a hole and find it everywhere. It is a limited resource, and so are your decent quality sands as well. So for building, particularly for mortar and screeds, and even concrete production, you do need very clean sand, and very clean sand is a little bit harder to find than you may suspect. So they are actually limited resources, is the thing. And so in terms of that idea of sustainability, can we go doing this same thing forever? Well, the answer to that is simply no, on that basis alone. Now, the thermal properties of masonry. It does have high thermal mass, and look, and thermal mass can be a blessing and a curse within the building. It's not just this idea of thermal mass is good, lightweight is bad. I guess for some of you might know Tropo Architects, so they started their design work up in Darwin, whereby the whole aesthetic or the whole idea is about building houses which are really lightweight construction and have as little thermal mass as possible. So you can provide shade and breeze to the occupants, but not have this building mass which is staying warm throughout the night. So during the day, yes, things heat up, etc. You cool it with an air conditioner, but during the night, you open them up and everything cools down really rapidly. So in many situations, particularly in the tropics, you don't want thermal mass. However, here in that more moderate sort of climate, thermal mass can work really well for us if it's appropriately placed. The problem with your brick veneer, however, is that thermal mass is not appropriately placed. It is placed on the outside of the building, so that brickwork heats up and then extrudes that heat throughout the night to the outside of the building. So whilst it can minimize the heat transference from when we get sun directly on a wall, I guess the benefits there are fairly minimal, and they're always possibly mitigated by a decent amount of insulation and reflective foil anyhow, so in any other building approach. However, if you flip your walls around and get that brickwork on the inside acting for you, then it certainly can be of significant benefit. So that's the idea of reverse brick veneer. Now, this whole term of reverse brick veneer, I guess it's called reverse brick veneer because it's essentially a reaction to the brick veneer as we know it. But many people building things like reverse brick veneer, not actually using brickwork, but any other forms of masonry or cast concrete, etc. But that reverse brick veneer is an umbrella term for whereby your walling system has its thermal mass on the inside, and then that's insulated and then clad on the outside of that with a lighter weight cladding. And also, so I guess we're talking about the unreinforced brickwork in its most commonly used form, which is brick veneer. There is now. There are plenty of houses you'll see around Adelaide that are of cavity brick construction as well. So that was the mainstay of construction from the 1950s through to about the mid 70s. So sort of in the mid 70s where this idea of brick veneer sort of kicked off, where people go, oh, actually we can do a timber frame and plasterboard cladding, sort of plasterboard lighting internally rather than two leaves of brickwork. So it's often referred to as double brick, but if we're going to be nerds about terminology, double brick is whereby you've got two leaves of interlocking brickwork, whereas cavity masonry is where you have a cavity in between two leaves of brickwork. So a lot of our construction, sort of the 1950s through to mid 70s, was of cavity brick construction. The reason we don't get there's several reasons we don't have that type of construction these days is, well, because it's thoroughly expensive. So there's a great deal of expense in the actual brickwork on a building. As soon as you go doubling that up, you've got a lot more weight to transfer to your footings. You've got a lot more cost of buying those bricks and a lot more cost of laying those bricks. But then also in that type of construction, what you don't have is you don't have an insulative layer within your building unless you provide like a 50 mil rigid insulation board within that cavity. So because brickwork or masonry, as one of its properties, is has very low insulative value. So just like any of these solid products, it will transfer heat quite well. Not nearly to the same extent that your metals will transfer heat, but certainly far more than timber and things like that. And as you are probably well aware of already, so our Australian standards that relate to masonry uses, both structural or non-structural, both AS4773 for your standard residential builds, so masonry and small buildings, and then AS3700 for masonry structures. So masonry structures covers all sorts of masonry applications, not just your standard residential builds, but AS4773 is specific for our class 1 type structures. So in this image, we can see this is the back end of a brick veneer wall. So this is before it gets the insulation and the plasterboard lining. So we can see brick ties. So those brick ties are embedded into the brickwork and nailed off to the studs. Now, the vast majority of brick ties these days are actually called face fixing ties. These ones are called pigtails, and these are attaching to the sides of the studs. These are a little bit easier to fix, but the reason that face fixing ties are used predominantly now is because if we have a look at this end of the wall here, we see that oriented strand board bracing on those studs. You can't get a pigtail past that. So you need to use a face fixing tie. And the other reason that face fixing ties are used a lot more now is also because you've typically got a layer of sarking on a building now, which I think is a very good thing. Definitely something I advocate for as a building practice. So those pigtails, they're located at 600 centers. So at every stud we have a brick tie, and then vertically at 600 as well. That's to ensure that brickwork actually stays tied to that main structural element, which is the timber frame. So the timber frame is providing the structural element for the house, and this brickwork is basically just a cladding for that. And then, of course, at the back of this brickwork, we've got lots of knobby bits of mortar and things like that, because there's no propensity for the bricklayers to go cleaning off that back face. What bricklayers do have to do, however, is keep this cavity free of any mortar dags and things like that that would transfer moisture to the frame. And that's why we have a 40mm cavity. That's why we have a 40mm cavity within the walls. Excuse me there. Yeah, and so that 40mm cavity is there to ensure that we don't get any transfer of moisture from that brickwork through to the frame. And then also these ties have a drip groove in them there as well, to ensure that any moisture that's making its way through the back of that wall drips down and onto the flashing there as well. Okay. In this image, we've got pointed brickwork. So that's brickwork that has been laid and then that mortar troweled off and then finished with a pointing tool to compress that surface and also dress it up. Eric's saying, is that a minimum of 40mm? So yes, so our cavity within here has to be between 20mm and 60mm, but 40mm is the standard. So yeah, because 20mm means it's a little bit more vulnerable to those mortar dags, touching the timber framing, etc. Okay, and within this image, we've got actually I'll get these around the wrong way. Oh, I meant to put this image first. Apologies. There. So this is that image of that brick on edge that shows that ability for that for the stonework, the stone facings to key into brickwork there. And then here are the stone facings that are going onto that brick on edge before they're pointed, and that's after the pointing. And of course, if we scroll back down to this image here, we can see all that that rough random brickwork used around these edges, because those are going to be rendered coins. So it doesn't matter that the mortar is pointed or not. In fact, it works a little bit better if it's all quite rough, because it gives the render something to key to. But then also it doesn't matter what that substrate is behind it as well, because it won't be seen. All right, so that is that covers our non-structural masonry. So as I said earlier on, it will be a bit of a shorter session today, covering that, and a bit of an early minute for you all. But before we go doing that, first of all, open the floor for any questions as well, before we then have a look at some of the example portfolios that people have put forward as well. So any questions, observations, etc. from today's session? No, all super quiet. Rightio. And just bear with me. I'll be with you soon. Just gonna. Okay. Rightio. So now then, switch around to having a look at some of the portfolios. So I'll stop this recording. So